Hello, welcome to the next section, Reinforcement Learning. In this section we're going to learn about reinforcement learning. We will discuss the premise of reinforcement learning. We will talk about the differences between reinforcement learning and supervised learning. We will go through some real-world examples of reinforcement learning and see how it manifests itself in various forms. We will also learn about the building blocks of reinforcement learning and the various concepts involved. Then we will create an environment in Python to see how it works in practice. Lastly, we will use these concepts to build a learning agent. Now we move on to the first video of this section that deals with what reinforcement learning is. In this video, we are going to understand reinforcement learning, look at some real-world examples, and study the building blocks of reinforcement learning. Reinforcement learning refers to the process of learning what to do and mapping situations to certain actions in order to maximize the reward. In the case of reinforcement learning, the learning agent is not told what actions to take. Instead, it must discover what actions yield the highest reward by trying them out. These actions tend to affect the immediate reward as well as the next situation. This means that all the subsequent rewards will be affected too. A good way to think about reinforcement learning is by understanding that we're defining a learning problem and not a learning method. So we can say that any method that can solve our problem can be considered as a reinforcement learning method. Reinforcement learning is characterized by two distinguishing features: trial and error learning and delayed reward. A reinforcement learning agent uses these two features to learn from the consequences of its actions. Now let's see where reinforcement learning occurs in the real world. This will help us understand how it works and what possible applications can be built using this concept. Game playing. Let's consider a board game like Go or chess. In order to determine the best move, the players need to think about various factors. The number of possibilities is so large that it is not possible to perform a brute force search. If we were to build a machine to play such a game using traditional techniques, we would need to specify a large number of rules to cover all these possibilities. Reinforcement learning completely bypasses this problem. We do not need to manually specify any rule. The learning agent simply learns by actually playing the game. Robotics. Let's consider a robot whose job is to explore a new building. It has to make sure it has enough power left to come back to the base station. This robot has to decide if it should make decisions by considering the trade-off between the amount of information collected and the ability to reach back to base station safely. Lastly, babies. Newborns struggle to walk in the first few months. They learn by trying it over and over again until they learn how to balance. Now that we've seen a few examples, let's dig into the building blocks of a reinforcement learning system. Apart from the interaction between the agent and the environment, there are other factors at play here. A typical reinforcement learning agent goes through the same steps. There is a set of states related to the agent and the environment. At a given point of time, the agent observes an input state to sense the environment. There are policies that govern what action needs to be taken. These policies act as decision-making functions. The action is determined based upon the input state using these policies. The agent takes the action based on the previous step. The environment reacts in a particular way in response to that action. The agent receives reinforcement, also known as reward, from the environment. The agent records the information about this reward. It is important to note that this reward is for this particular pair of state and action. Reinforcement learning systems can do multiple things simultaneously. Learn by performing a trial and error search. Learn the model of the environment it is in, and then use that model to plan the next steps. So I assume you have a fair idea about reinforcement learning now.